Alrighty guys, so this is lesson 17 and we are going to be finding inverses and graphing inverses, okay? So basically you guys, this is what an inverse looks like in relationship to the original function. So if this right here is the original function, okay? Now if you took that paper that you're writing on and you folded it across that line right there, and the equation of that line is y equals x, then where would that green, like if that green was wet paint, where would it go? Well, like this part right here, like these would match the same. And see this dot right here, it would come over to the other side. And this part that kind of bulges out would come right there. And this part would come right there. And if you fold it across that line, y equals x, then it would lie right on top of the other side. So the green would smear right over there to the yellow, okay? Here's another thing that is true about inverses. Do you see this point right here? That's a times b. So on an inverse, you reverse it, and it's b times a. So this, for example, if this was 2, 3, then over here, it would be 3, 2. So you can just reverse all the points if you want to, okay? So here's question 1, draw the inverse, okay? So here's what I do. First thing I do is I draw the line y equals x. So I want you to draw that in, okay? And then, do you see where that black graph touches the line y equals x? I want you to put a dot right there because the inverse is going to touch in the same place. Okay, now I'm going to show you something right now that's kind of strange, but it works. And my opinion is it's the easiest and fastest way to draw an inverse. When I talk about a diagonal, I'm talking about the corner of one of those squares to the other corner. If I talk about a half a diagonal, I'm talking about half the distance of, a diagonal, basically. So if you look at this point right here, if you folded it across that line right there, that y equals x, do you see how that's a half a diagonal? So you would go continue in the same line half a diagonal away, and that's where that point would go. So it would go right there. See this guy right here? Draw a line to that line of reflection, y equals x. Continue along the same line, same distance, which would be half a diagonal, and it would go right there. This point right here, half a diagonal. Continue the other side, half a diagonal. Now all those half a diagonal measurement things are actually kind of confusing. So I want you to just erase them because you wouldn't really draw them. You would just kind of, estimate it. And then you would draw this in so it would look like this. And I know I'm right because if I fold the original black graph over that line of reflection, it's going to lie right on top of the purple graph. So that's what it looks like. One more thing. So don't erase yours, but I'm going to erase mine. So look at the black graph. If that confuses you, okay, look at the black graph. And what I want you to do is to write down the ordered pairs of the black graph. And I want everyone to do this, whether you understand the half diagonal thing or not. So this ordered pair right here is left 2, down 1. So that's negative 2, negative 1. This guy right here is left 1, don't go up or down. That's negative 1, 0. Him right here, he's maybe 1/2, 1/2. So I'm going to go 0.5, 0.5. This guy is right 2, up 1. So to find the inverse, that's the notation for the inverse, all you do is take those values and flip them around. So negative 1, negative 2, 0, negative 1 still stays 0.5, 0.5, and it goes to 1, 2. So then I could plot those points. So left 1, down 2 puts me here. Don't go right or left, but go down 1. 0.5, 0.5 is here. Right 1, up 2, draw it in, and I get exactly the same graph when I did the folding. So either way is fine. I just basically showed you two methods. I think just to see the distance and carry on the other side of that line y equals x is easier, but you do whatever makes sense to you. Okay, so now we're going to find an inverse. So basically, I'm going to give you an order in which I think you should do these things, and I think you should follow the order because I think it's going to make it easier, okay? So here is example 2, okay? So step number 1 is going to be to graph f of x. Okay, so let's do that. So you have y equals 2x minus 4. Okay, that's a line. The negative 4 is the y-intercept, so go down 4 and make a dot. The slope is 2 over 1, so put your pencil on that dot, go up 2, right 1. Do it again, up 2, right 1, again, up 2, right 1, up 2, right 1. Draw that line nice and long, okay? Draw it very accurately, draw arrows on the end, and label it f of x, okay? The next thing I want you to do is to find the domain and the range of f of x. Well, domain is x, start small. If I'm over here at a negative x, will I ever hit that graph? Yes, it's going to be down here. What if I'm here? Yep, it's going to be about right there. How about here? Yes. How about here? Yes. 1 hits it, 2 hits it, 3 hits it up here, 4 hits it. Forever is going to hit it up here. So the domain is everything, okay? They didn't tell me how to write it, so I'm just going to say all real numbers. The range of that graph is the y. Here's your y-axis, start small. So if I'm down here, could I ever go right or left and hit that graph? Yeah, it's going to hit about right there. How about if I'm, up a little from that? Yep. How about here? Yes. Okay, so this is negative 5 is going to hit it, negative 4, negative 3, negative 2, negative 1, 0, 1, 2. What if I'm really high? Yes. And that is everything. Okay, so my range is all real numbers. Okay, step number 3 is to find the domain and the range of the inverse. And then I want you to put switch. So guys, the domain of the function is always going to be the range of the inverse. So whatever you get here is automatically going to go there. The range of the function is the domain of the inverse. Those are always going to match. Okay? Step number 4, I want you to graph the inverse. Well, how can I graph the inverse if I don't even know the equation yet? Well, you've got a graph of the original. So grab your pencil, draw in the line, y equals x, and do the diagonal thing, okay? So do you see how right here is where those cross, okay? So I'm going to put a dot right there. See this point right here? Half diagonal, go to the other side, half a diagonal. This guy right here to the red line is a full diagonal, other side, full diagonal. This guy right here is a full diagonal and a half. So go full diagonal and a half and it goes there. This blue one is 2 diagonals. So this is going to be 2 diagonals. I'm going to connect my dots and there's my inverse. You can tell that it's right, you guys, because if I take the original blue graph, fold it across the red line, I get the purple graph. Label that purple graph f inverse of x. And then the 5th thing that I want you to do is to find the equation for the inverse. Now you have to show work for this, okay? So to find an inverse, you're going to switch the x's and y's. So my y becomes an x, my x becomes a y, and then I just solve for y. So to solve that for y, the 4 comes over. So I have 2y equals x plus 4. And then I divide by 2. I'm going to divide these separately by 2. And then I get y equals, you guys, x over 2 is awkward. So push the 2 out in front of the x like that. It's still on the bottom. And the number on the top would then be a 1. And then 4 over 2 is a 2. That's the equation. But don't write it as y equals. Write it as f to the negative first of x equals. That's the symbolism for the inverse. Okay? All right, let's do example 3. Follow those steps. Okay? So The original equation is y equals x minus 3 over 3. Okay, that's super awkward. So, because I want to graph this thing. So I'm going to divide these by 3 separately. So then that gives me y equals, I've got my x, push the 3 in front of the x, but it's still on the bottom. So that would be 1/3 x minus 1. So step 1 that I just gave you on problem 2 was to graph that. So let's go down 1, make a dot. From there go up 1 right 3, up 1 right 3, down 1 left 3, down 1 left 3. You guys, the more dots you make, the more accurate your graph is, and the less confusing this problem is going to be. Okay, so draw it and label it f of x. Find the domain. Domain is x. If I'm really negative, that's where I start. I'll touch it. Even if I start moving to the right, I'm still touching it. -1 touches it, 0, 1, 2 touches it, 3's right on there, 4, 5. If I go really far, it's up, so my domain is everything. Range is y. If I'm down here low, if I move to the left, I'm going to touch it over here. Even if I go lower, it would just be further left. Here touches it, -2 touches it, -1, 1. How about if I'm up here to 4? Yep, I just have to go right. Higher up I go, the more right I go, but it's always going to hit it. So the range is everything. The next step is to find the domain and the range of the inverse by reversing those. So those just get switched that way, so it's still all real numbers. The next step that I gave you was to graph it. Always graph the line y equals x. So that's always what I'm going to do first. Okay, so it looks like that. Okay, so put a dot where those two things cross. Let's get a few points. This guy right here, half diagonal. This guy right here, half diagonal. This guy right here, diagonal and a half. So it goes like that. I'm going to, 3, -2. I think it's just over a little bit from where I'm at. I think I'm good. That's kind of weird. I don't know what's going on. Half diagonal, half diagonal. Maybe it's just up a little more than what I've got. So I think I'm good. I think what I'm going to do is just like double check my numbers. So basically that's it. Okay. And then I've got my inverse. Okay. Okay. The next thing I'm going to do is find that equation. Don't find the equation from the graph, do it algebraically. So y equals becomes x equals, and the x becomes a y. Then solve it for y. So move your 1 over. So you have 1/3 y equals x plus 1. I want to get rid of the 1/3, so I'm going to multiply this and this and this by 3. So I get y equals 3x plus 3. And remember not to write it as y equals, write it as f to the -1st of x equals, and there you go. Let's double check our graph. Up 3, make a dot, down 3, write 1, down 3, write 1. Yeah, it's totally good. That's it. Okay, here is example 4. Try to remember the steps. You don't have to do it in the order that I'm doing it, but I think it is a great way to do it. So I think it's the easiest. So the original graph is y equals -x plus 3. Let's graph it. Up 3, make a dot. The slope is -1 over 1. Down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1. Connect your dots. Okay, make sure you label it. So call that f of x. You guys, the domain and the range of a line is always going to be all real numbers. So these are all real numbers. Flip-flop them, you still get all real numbers. Draw in the line, y equals x. So it looks like that. Okay? Now, this is weird because I'm trying to fold the blue line across the red line. Look at this dot right here. It's a half a diagonal. If I go half a diagonal on the other side, I'm just going to get that point. This one's a diagonal and a half. If I go diagonal and a half on the other side, I'm going to get that point. So it looks like if I fold this half across the red line, it's just going to lie right on top of the other half. So it's kind of strange. Let's kind of skip over that and let's go to the equation. So you have y equals. So I'm going to have x equals. Negative x is negative y. So I just switch my x's and y's. Solve for solve for y. So you have negative y equals x minus 3. Change the signs and you get y equals negative x plus 3. Take your y, get rid of it, replace it with the symbolism for the inverse. So now it's so strange because the inverse is the same as the original equation. Well, sometimes that's going to happen. If you draw a line and when you fold it across the line y equals x, it lies on top of itself, then the inverse is going to be the same as the original. So let's do this. Let's draw a double arrow and let's right here say and f inverse of x, and I'm actually done. So the reason that happened is because f of x is symmetric across the line y equals x, meaning if I take this half of my graph and fold it across the red, it lies on top of the other half. If that happens, then the inverse and the function are the same equation. Okay? Okay, so question 5, explain how you could graph an inverse without first finding the equation of the inverse. Well, that's what we keep doing, okay? So here's what I would do, okay? I would say first, comma, I would graph the original equation. Next, comma, I would graph the line y equals x, okay? And then I would say, last, I would measure, we're not really measuring, but we'll say measure the distance between the original equation and the line y equals x, okay? And then I would say I would go the same distance from y equals x on the opposite side of the original graph. Original graph is great. Okay, so that's totally an option. Another thing you could say is this. First, I would graph the original equation. Next, I would graph the line y equals x. Then you could say, I would take the ordered pairs in the original equation, switch the x's and y's, graph those points, and that would give me the inverse. So either one of those is fine, okay? Okay, guys, so you have 2 assignments due next time you come to class. So assignment 16 and 17 are both due the next time you walk into class, okay? Thank you.